Number 6, do the following limits exist? Explain why or why not. All right, just to recap, in order for a limit to exist, the limit as x approaches a value, I'll just put a from the left side, must equal the limit as x approaches a from the right side. So coming in from the left and coming in from the right, you must be approaching the same y value. So if I would like to find the limit as x approaches 0, as I'm approaching my function, as I'm approaching 0 from the left, I'm approaching a y value of 2. And as I'm approaching from the right, I'm also approaching a y value of 2. So since my limits match each other, they both equal 2, I would say yes, and that would be because the limit as x approaches 0 from the left is equal to the limit as x approaches 0 from the right, which actually happens to be 2 in this case. All right, the next one, we want to find the limit as x approaches 2. So again, I'm going to take that exact same approach. As I'm approaching 2 from the left, I'm coming into a y value of 2, it looks like again. And as I'm approaching from the right, I'm approaching a y value of 1. So 2 definitely does not equal 1. So in this case, no, the limit does not exist. And the reason would be is that the limit as x approaches approaches 2 from the left is equal to 2. And the limit as x approaches 2 from the right is equal to 1. Those two limits do not equal each other. All right, number 7, the function f has a first derivative given by f prime is equal to 1 plus e to the 2x minus x squared, and it asks for what is the x coordinate of the inflection point. So if I'm looking for inflection points, I know I'm looking at f double prime. I notice that I'm already at f prime. So to get to f double prime, I just have to take the derivative one time. So let's see if we can do this. Okay, the derivative of 1 is just 0. Okay, the derivative of e to anything, remember, is just e to the same thing, and then we have to multiply by du. So this one, the derivative of e to the 2x minus x squared is e to the 2x minus x squared, and then I have to multiply by the derivative of the 2x minus x squared, which will be 2 minus 2x. Right, now from here, if we want to find a point of inflection, f double prime would have to change sign, so I'm going to make an f double prime chart, which means first of all, I need to figure out where does this second derivative equal 0. Okay, and hopefully from your study of e to the function, please remember that this, if it's an e to any power, it's never going to equal 0, and it's always going to be actually a positive value. Okay, so I don't care about this for getting a critical number, but if I set this part equal to 0, I know x would have to equal 1. So if I do an f double prime chart and put x equals 1 on it, and then I'm going to test things into f double prime, please remember when I'm testing it in, I know this part out here is always going to be a positive value. So let's say I plug in 0. If I plug in 0, I'll get a positive times a positive, so that gives me a positive. And then let's say I plug in 2. If I plug in 2, I'm going to get a negative times a positive, which will be a negative. So x equals 1 is a point of inflection, and that would be because f double prime changes sign. Okay, number 8, let f be a differentiable function with f of 3 equals 7 and f prime of 3 equal negative 9, and let g be the function be defined by g of x equals 2x f of x. Which of the following is an equation of the line tangent to the graph of g at the point where x equals 3? And use the hint, you will need to use the product rule. Okay, so we are asking for the equation of the line tangent, which in my mind tells me y equals mx plus b. When I'm done, that's what it's going to look like. All right, and I know I need to get m, and when we're studying functions and using calculus, m is a derivative, and since it's an equation line to g, we know we're going to be looking for g prime. Okay, so I'm going to start off, this is g, which is 2x f of x. All right, so I know I need to get g prime, and I do notice there's a product, so I think I'll use the hint that I need to use a product rule. So this will be f and this will be g. All right, f prime, the derivative of 2x is 2. G prime, the derivative of f of x is just going to be f prime of x. So just don't make that more difficult than it is. All right, so g prime of x is equal to f prime g, so 2f of x plus f g prime, so 2x f prime of x. So that's pretty much going to be my slope, but I do know that it's going to be happening at x equals 3. So I'm going to go ahead and plug 3's in for all of my x's and see if that helps me out. Okay, and I do notice this. It does help me out because they told me what f of 3 is. F of 3 is equal to 7. And f prime of 3, they told me, was equal to negative 9. So this is going to be 14 minus 54. And then 14 minus 54 is negative 40. So g prime of 3 is negative 40. And again, what that found for us was that the slope of my function, or of my tangent line, is negative 40. Okay, so now I'm going to go ahead, plug in what I know here. I just found out that the slope is equal to negative 40. I also know my x value is 3. I do not know my y value, and in this case, my y value would be a g value. So I'm going to do a little bit of investigative work here. We know g of 3 is equal to 2 times 3 times f of 3. Notice I just plugged x's in, 3's in for all my x's. And again, they told me that f of 3 was equal to negative 9. So I know that g of 3 is equal to negative 54. Did I do that right? Nope, because f of 3 was equal to 7. So let's redo that here. So that would actually be 42. There we go. Okay, so this just gave me my y value, which was 42. So now I have 42 equals negative 120 plus b, which means b must equal 162. And so the equation of my tangent line would be y equals negative 40x plus 162. And we got it. All right, question number 9. The graph of the derivative of a function f is shown in the figure below. The graph has a horizontal tangent lines at x equals 2 and x equals 6, and you notice we can see that. At which of the following values of x does f have a relative minimum? Well, if I'm talking about relative minimums, I know that I need to make an f prime chart, so that's exactly what I'm going to do right now, is make my f prime chart. Okay, since this is a picture of f prime, remember, we'll just be looking for where does f prime equal 0. So it will be here, and here, and here. So it looks like that's happening at 0. And then that looks like about 4.5. And then again, it looks like at about 7. Okay, so before 0, f prime is below the x-axis, so that will be a negative value. Between 0 and 4.5, the graph is above the x-axis, so f prime will be positive. Between 4.5 and 7, f prime is below the x-axis, so f prime will be negative. And after 7, the graph is above the x-axis, so f prime will be positive. Okay, if I want a relative minimum, relative minimums occur where f prime changes from negative to positive. So I'm going to be looking at x equals 0, f prime changes from negative to positive, and then at 7, f prime changes from negative to positive. So D will be my choice for that one. Okay, number 10. The radius of a sphere is decreasing at a rate of 3 inches per second. At the instant when the radius of the sphere is 9 inches, what is the rate of change in cubic inches per second of the volume of the sphere? Okay, looks like a related rate problem. So we're changing with respect to time. So when it tells me about the radius, how fast the radius is changing, I can put dr dt is equal to negative 3 because it is decreasing. Okay, then it says at the instant when the radius is 9, so we can put r equals 9. And then it says, what is the rate of change of volume? So it's asking us for how fast is the volume changing. So dv dt equals question mark. Once we have our information, we need a formula. And they nicely provided us with a formula. And so from here, I'm actually going to take the derivative. The derivative of v with respect to time would be dv dt. And then the derivative of the right side, I'm going to bump my 3 out front, which would give me 4 pi. Decrease my power by 1, so I'd have r squared, and I am taking the derivative of r with respect to time. Okay, from here we're just going to plug in what we know. We know the radius is 9, and we know dr dt is equal to negative 3. So just working that out, this is in the calculator section. You can just use your calculator. I don't have my calculator right in front of me, so I'm just going to do it by hand. I'm going to get 9 squared is 81 times 4. That will give me 324, and then I have to multiply it by that 3. So it looks like I'm going to get negative 972 pi. And again, you could have a decimal for that. That's fine. And it said we're testing the volume, and it's measured in cubic inches per second. So inches cubed per second.